Hear me okay? All right. Well, as Mike mentioned, my name is Mike Benchoof. A little bit about me. I am a technical account manager for Percona. I originally had been on their consulting team for a few years and have unfortunately gotten out of as much of the coding and switched to more spreadsheets and client stuff. So I enjoy giving these types of talks. It gets me an opportunity to go back and mess around with code and to actually start to do some technical things again. So we'll go ahead and get started. So just a general question, what is geodata? Everyone here, I'm assuming that's come to this talk, is familiar with what that means and what it is. Basically, we're looking at a wide array of topics. You can use this for geopositioning data. That's really what we're talking about here. So latitude and longitude, defined areas, bounded areas. This is really what we're talking about when we talk about geodata. And generally, just having those points and the actual spaces defined isn't enough. There's generally some function of distance that comes along with this. So again, why do we care? Types of questions that we normally see or get asked as developers or as consultants or that type of thing. What are the 5 closest restaurants to my hotel? These types of questions. How far is it from here to the airport? How long is it going to take me? Am I going to be late if I leave right now, given traffic and distance? These are common questions. And then with the prevalence of geo-enabled devices, so I'm assuming everyone here has location services turned on their phones, and so those types of questions are automatically asked, right? I Google something, it immediately knows where I am. It can find the things that are close to me. Unless anyone's paranoid and they turn that off and don't want people to know that, that's another option. When you look at this with other industries, oil and gas exploration is one, that's for sure. Meteorology, logistics companies. Really, the point is, any industry, if you're not already using it, likely at some point you're going to need to be using geodata. And you probably may already even be using it in your companies and not even know it. So everyone's favorite exciting stuff, theories, formulas, drawings. So basically when we look at this, we're talking about the distance between points on a sphere. So that's when we're talking about distance in MySQL or in applications. Unfortunately, we can't just do everything on a flat surface. We're looking at distances on a sphere. So looking at the Haversine formula, I've got it up there. So if anybody wants to enjoy coding that, that's fine, but that is the actual calculation to determine your distance between points on a sphere. So again, when we want to do this in MySQL, we're talking about before 5.6, and I'll stop for a second. Is everyone kind of familiar with the different versions of MySQL, or are people using MySQL here? Okay. So they've kind of started to change the numbering scheme, but we had 5.0, 5.1, and then it jumped to 5.5, 5.6, 5.7, and now they've decided to change how the conventions are going to go, and now we've got MySQL 8. I've got upcoming here. It's not available in GA yet, but it is definitely where things are going. They don't really give us release dates for when that's going to happen, but the current generally available release is 5.7. And this will kind of walk through how geodata has been handled in MySQL. So prior to 5.6, nothing was really supported, and I'll kind of caveat this with, if you use MySQL, you're probably familiar with the differences between InnoDB and MyISAM, and generally what I like to say is if you actually care about keeping your data in said database, never use MyISAM. Well, that was the only option that we had to store geodata. So they had the geospatial type in MyISAM, and we recommended to never use MyISAM. So that was kind of a problem there. In 5.6, they started to add some new functions and realized that geospatial was where things were going. But again, they still only focused it on the MyISAM piece. It was available in InnoDB, but they did not allow spatial indexes, and we'll get to the impact of that later. In 5.7, so the current release, we've got additional spatial functions, and then we've got spatial indexes added to InnoDB. So now you can actually store your data in InnoDB, transaction safe, the whole thing, and actually use indexes, which makes it usable. And then in 8.0, which is coming out, The highlight is that everything prior to this point has been based on a flat plane, and now they're adding in support for actual spherical references. Any questions so far? Pretty basic stuff. So here is that earlier Haversine formula, and this is how we actually want to go ahead and calculate these things. So what we're doing here, this is just a very quick sample. I said, okay, I'm going to do the difference between two latitude lines, right? So we set our destination, our source and our destination latitude and longitude, ran through that lovely formula, and ended up getting 69 miles, which fortunately is the actual distance between 2 points roughly on a sphere. So this kind of shows that the actual formula can work, and you can use that to get your data. But that's obviously not a really elegant way to have to do that every time. So if we take that formula and we take the kind of rudimentary way that we would store things, and we also say that I want to use NODB, so we're taking my ISAM off the table, and we had to use, prior to 5.6, we would have had to create our table, and this was the traditional way. So I don't know if anybody's ever seen a table like this, but kind of this was how MySQL we did geospatial. You had a column that was a decimal column for latitude and a decimal column for longitude, and there was your table, okay? Nothing actual geospatial about it, but you could track distances and points from that. So we would have to go in and we'd have to write our own helper function. So instead of calculating that on every single time throughout our formula, we would go ahead and we could create that formula and say, give me my distance in miles between a source, basically source points, but those are going to be done in decimals again, so we're not using points at this point. And we're going to return our long formula that we had, and this is actually going to be able to get us our distance on a sphere, or on a flat plane. So let's take an example. We've got our table here, and we set the actual, the geographic coordinates for the Norman Post Office, and we go ahead and say, now find me all the zip codes that are within that. So I have a table that has all the zip codes with lat and longitude for each as an actual decimal column. And we go ahead and we can run this. We use our helper function there. You see distance in miles, and we're able to calculate them sort of by distance. And you look at this, and I fetch 10 rows in a half a second, which is not great. Granted, I'm just running this on a local VM, but still, that's not what you'd consider respectable. So let's look at the explain. Are people familiar with how we use explain in MySQL, or what that is? If anybody's not, just basically what it is it's going to show you the query execution path and what actually happened when you ran your query. So we can find out that question when they say, hey, the application's running slow, or this query is running slow. We can use the explain plan to figure out why it's running slow and hopefully optimize it. So right here, the worst part that we see is type all. That means I went through every record that I had, and I just basically read the whole table into memory and went point by point through it. So as we can see, this query worked, but it didn't use any indexes. So every time I'd run this, I'm going to scan my whole table. When you look at a large table, this only has 42,000 rows because it's 42,000 zip codes. If you're looking at this with, where are all the users on Facebook, it's probably going to take a little bit longer to do that as a table scan over and over again. So what we did, again, prior to 5.6, is we took the feature that you can still add an index, and we used that to kind of shrink down our results. So we used what was called a bounding box method. And we would take that 69 miles, the 1 degree of latitude and 1 degree of longitude, and you'd have to pre-calculate this in your function. So you would go through and you'd say, okay, give me my corners, and then let's draw this box. And now what I can do is I can add in my where clause and actually shrink down the size of the area that I'm scanning. So now I'm not scanning the full table anymore. I'm just scanning specific smaller rows. And you can see now the new explain plan is a range, and I only went through 1,600 rows because I shrunk it down, and my result set time dropped from half a second to sub 100th of a second. So now we're at least getting to something respectable, but it's still a lot of manual work that you had to do, and it's not really an ideal way to do it. So as we pass to go through, kind of the next step is how MySQL converted this and now moves to use the spatial data types. So again, we just went through how we did this in the non-spatial way. We had individual decimal columns and then the typical composite index that covered those two columns. But now when we look at the spatial way, we've introduced this point type. So that's a new data type that's in MySQL. So instead of just your typical ints and strings, now we can also do a geospatial point type. And you can use those with a type of a point, of a polygon, and different geometric shapes, which now starts to open things up. So the other nice thing is that, again, in 5.7, we can now add spatial indexes. So when we look at our table, now we take our old table, so that's, as you can see, legacy zip codes against geospatial zip codes. Really, the main difference I highlighted up there is that you can see instead of that latitude and longitude, we now have the geometry field or the geo field of the geometry type instead of using the decimal types. And then we've also added, instead of that lat and lon composite key, we've got a spatial key, and you can see that it actually changes it. Normally it's either primaries or uniques. Now we actually can define that as a spatial key. And now look at our function. It's a lot nicer and a lot more logical query. Instead of having to go calculate all that, I basically just say, give me my starting point and find things that are within that. So this is allowing me to go ahead and do the exact same types of queries that I was doing before, but in a much more logical way and less calculation that my application has to do. I can just plug this right into MySQL. So again, we already had a query written to do this, so really what's the difference here? It does the same amount of handler operations. If I ran that same query that I was doing before, it was the same 1,600 operations because I'm looking at the same number of zip codes. The real big benefit and why we actually care about this is because now I can do other GIS calculations because I have a geometry type and I'm not just limited to my decimal columns that are there for just a point. So we were using everything based on that single latitude, longitude, and a lot of, you can find, if you just Google, give me a zip load or a zip code database to download, a lot of them are going to be in that model. You have a lat and a lon column in there. You load it, great, because people want to know these types of things. Now people are starting to use those full polygons instead of just the decimals. And one example, this is an older one. They have a new one. I just didn't feel like going to re-import it. The US Census provides an updated database that actually follows a standard zip code type database, but it uses the spatial data. And you can convert that from the raw points file into MySQL. It's kind of outside of the scope of this, but there's a couple tutorials on how to do that. Okay, so when we look at the table that comes from that, so now we've got, as you can see, they name things very obvious to understand there, but basically the ZCTA5CE10 is going to be what your actual zip code is, and then they have the shape field, right? So now, when we look at that, before, when I had my single point version, I just had, okay, here's the center of it, and I had to kind of calculate that box to find things that are around it. Now, when I look at the exact same zip code in that shape database, I actually have a polygon, and you can see basically it's going around the entire city limits, and it's marking each spot, and I'm getting a fully defined area. It's not just a square that's kind of close. It's the actual, if I step past 35, negative 97, I'm going to be outside of Norman at that point, or outside of that zip code. So, I mentioned that as coming along with this and not having to calculate all this on your own, we started adding more of these GIS functions. So ST contains and ST within are kind of the big ones that we want to use. And these are checking to see if something is kind of spatially within or contained within another item. There's an entire list, again, going through them. I don't want to bore you all to death. There's the manual, you can look it up, and basically there's an entire list of ST underscore, and those are going to be your spatial functions, and you can see the different things that you can do native within MySQL. So when we look at some sample queries, so you remember kind of how ugly those were and the extra math that we had to do. What's really nice is that not only are there these functions that we can do to calculate distance and calculate various contains and within, you can use those as part of your join. So now I've got my table that has all of my polygon data, and I can join that against another thing, and when I'm joining it, instead of just joining on a value, I can join on that function. And that's going to allow me to quickly find all those. I don't need to select all my points and find out where they are. I can just say, here's some points I have, here's the defined areas I have, join the two and show me all that are there. And now my result set's gonna come back and it's gonna tell me which point these are all within, and that's gonna be there that I can use. Same type of thing here with this next one. When we look at, points of interest within a zip code, that's the same type of thing, but now I can do extra joins around that and see I have in the middle of that my ST contains as one of my join fields instead of just a regular on something. But then I can still join it down multiple tables and go ahead and actually use some of the other values there. So again, just another step going even further. We're joining with the legacy zip codes that also now define your counties and all types of good stuff. So it opens up the possibilities where now I don't have to just say, if I don't give exactly this query with exactly these decimals, it's going to be horrible. It allows you to start using the power of how you can actually write relational SQL, do your joins, but use it in a geospatial format. So I talked before, and it was something that I just kind of glossed over, but we added spatial keys. Just kind of want to go through the importance of that. And again, as we talk about this, when we look at joining tables, right, you want to join on an index. You don't want to join against a non-indexed field. When you do that, you're going to end up trying to do full table scans on your join, and it's going to be slow, and your memory is going to be horrible. All those problems are there. So the fact that we added spatial keys and we're now able to join on that, that makes this usable. So it was there before, but you really couldn't use it. It just didn't really help. So let's look at one of the queries that we had before. And so I ran that query, and I have the same table, one that had the spatial key and one that didn't. When I didn't have the spatial key, it took me a minute. When I had the spatial key, it was under 1/100th of a second. So we can see right here, and you can see in the handler operations, what it was doing is for each one of those, because I don't have that key, I was doing a full join and scan on that other table over and over again. So I only had 4 points, but each time I had one of those points, I had to scan the whole other table. And it's not usable. So that's why I was saying that it was available, but nobody used it because there was no indexing on it, and everyone knows if you're going to query something, you want to query it based on indexes. So the MySQL 8 stuff, again, it's not GA yet, which is unfortunate, but we're assured it's coming soon. So we've added the spatial indexes. That was done in 5.7, but in 8.0, now we actually are doing it based on not being on a flat plane anymore. So if you notice on here, before everything was close. It still wasn't exactly accurate, but it was at least got you to where it was. Now we're actually basing it on the ellipsoid, which is very helpful. They started with ST distance because distance is the thing that people care about the most, and they're starting to add that into all the other functions that were in that long list of all the STs. So some of them you would still have to write your own helper functions, but since I did these slides, I'm not sure which ones, but they basically said they're just going through as fast as they can and adding that support into each one of these functions. The ST as text, that was one that was very frustrating. If something was stored, you had to figure out, am I in Latin LAN based on everything correctly, or do I have to switch things around and rewrite my code, or rewrite how the query's coming back? Now when I give it a spatial reference system, it makes sure that it's giving me something that makes sense. It's not going to give me a point in the middle of the ocean when I'm looking here because I put them in the wrong order. It's going to know these are the types of things that are valid. And that brings me to the last point here. SRID 0 is basically what MySQL always used. It would allow you to specify another SRID, but it would just kind of silently ignore it and not care about it. They've added the 4326 SRID, which is the standard one that's used for geospatial stuff. So that was the first one. Again, they're working on getting more in there, but they're trying to support more coordinates systems as they can. Okay. So any questions on any of that stuff? I just got a quick little demo that I put together. And so this is why I was kind of asked, so please no one judge or criticize my Python code. I am in no way, shape, or form a Python developer, but it's the one that I have to, if I have to write a script to do something, I'm going to not use bash, basically. So what it'll do, this demo, I turn on something that is going to track my path and store it in the GPX format, which is a standard format. And then I'm going to take that raw file, I'm going to load it into MySQL, I'm going to get the geodata about each point, and then I'm going to calculate the distance that I drove in each area. So I put this on, I went out to New Mexico for a hunting trip back in September. I forgot to turn it on when I started, but I remembered in Albuquerque, and then I drove all the way back. So it's got, you know, a 10-hour drive calculated here, so we can see how well that does. All right, can everybody see? Okay. So again, here is kind of the rough code, and there's a lot of things that you can do, and this is something that when I was more on the consulting side, I would fight with clients a lot, and they would say, well, I can do this in the database, so I'm going to put all my business logic, and I'm going to do all that in the database. Sometimes that makes sense, but a lot of times when we're talking about performance and we're talking about giving developers more control over things, we don't want all that stuff in the database. So a lot of these functions I could have calculated in the database, but instead I used a Python library and just calculated them in the code and used MySQL for the heavy lifting of just saying, do that big join, get me all the geographic information, and then do my calculations in the app. So I'm not just running functions over and over again in MySQL for each point. So I've got some sample ones here. So we will run this. Okay, everybody can see that. We'll see how long this was. How about I go to the right directory? That would be helpful, huh? Actually, log into the server. All right. And again, this is running on like nothing with anything. So right there, we had a 630-mile trip, and in 14 seconds it went through, took all the points from that, and got down to their, using that US Census database, got me the geographic information about each point, and then I was able to use the Python library to say, okay, what state am I in? Let's track each state and get the distance between the points, and then get an aggregate there at the end. So again, it's definitely, it's not the most elegant code, but it gives you the idea of the types of things that you can do. So here's another one that we could use. This is, as you can gather from the name, this was the drive to my in-laws' house, which they are in Oklahoma, so giving you the state data there doesn't really make any sense. But again, this is a shorter drive. They're only a couple hundred miles away. So. Do what? So yeah, so let me come back over here, and I think I had one or two slides left. We're going to do this nonsense. Okay, so again, here's just kind of under the hood. This is what that was running. Now, if you were listening earlier and I showed you a query that had type all, and I said don't ever have type all because it's bad, because that means you're doing a full table scan, this is one that we've actually put in a request because it comes up and says all, but talking to the developers, it actually is using the index. So because this extra you can see down here is that it's doing a range check for each record, the actual rows and handler operations that it's doing are correct. So this is more of a explain bug than it is what's actually happening. So that was one that I did want to highlight. Even though it looks like it's all, it definitely isn't. And what I can show you here, so you can see, it thought I was going to do hundreds of thousands of operations, and really over a 10,000 points, it did, 20,000 operations. So I think that's pretty decent in terms of trying to calculate the mileage between those types of areas. And again, this is just some silly application, but it gives you the idea of what you can use it for. So that's pretty much what I had. Does anybody have any questions or comments or clarifications? Ready to hear me stop talking? Bored? Food coma? I don't know. Yes? Can you say that one more time?
Basically, how do you see this relating back to ArcGIS software?
So the question was how does this relate back to, you said ESRI?
ArcGIS, ESRI, they're like Microsoft.
Right.
ArcGIS is Word.
Okay. So I'm not really sure how to answer that. I think really the main thing that I see from this, I wouldn't see this necessarily as being any type of competitor. This would just be a way that you could do this in an open source and do this in more of an open source and flexible way. I don't really see it as kind of a competitor, like this is going to replace anything. This would be more in supplement, or if you're already using MySQL in your infrastructure. Does that answer your question? Is that okay. Anything else? No? All right.
Thanks, Mike. I just wanted to point out that